Hey guys, this is your lesson for sunspots and other features of the sun. Basically wrapping up with the sun's structure, and now we're going to talk about certain parts of the sun and certain things that happen due to the sun. And so the way this is going to work is there's this video that you're watching, and you're going to pause it and answer questions as you go along. And so to start this video off, I wanted to just make sure I take this time to go over some material again. I've gone over this in multiple videos this week. Hopefully you've been watching these videos, the general everyday videos that I put up. I go over things. I go over assignments and make sure that people know what they were getting wrong and things like that. But this is also a good opportunity to go with it again. So gravity is the first thing we're going to talk about before we start with this worksheet. So we're not even worried about the worksheet yet. We're just worried about what's on the screen for the PowerPoint. And I just want to make sure that you understand that gravity increases as mass increases. So the bigger a planet or the bigger a sun, the more gravity that it's going to have. And gravity also decreases as distance increases. So if I was to take the Earth and move it further away from the sun, there would be less gravitational pull between those two things because it was moved further away. All right, solar systems, as long as you know that they always start with a nebula and they always end with planets, I think you'll be okay. Talking about the structure of the sun, we know that the core is in the center, or the most inner part of the sun, and in the core, nuclear fusion happens. Nuclear fusion basically takes two atoms of hydrogen and it fuses them together or forces them to come together. And when that happens, it creates a ton of energy. And that's why the sun is just this giant ball of energy. Couple other things. After the core, you get the radiative zone and then the convection zone. And in the convection zone, hot plasma and gases move outwards towards the atmosphere of the sun. And when they reach that atmosphere, they're more out in space rather than towards the core, and so they start to cool off. And when they cool off, they start falling back towards the core and they heat up again. Kind of like magma in the Earth or boiling water. The hot molecules move up and the cold molecules move down. It's very important to know convection. And then lastly, the photosphere. The only reason that we see light from the sun. That's going to become important, especially today as we talk. All right, photosphere has all the light in the sun. We cannot see any other light except for what's on the from the photosphere. So with that being said, we're going to go ahead and get started. And I'm looking right here. It says, does the sun rotate in place? So I'll put that slide up right now. And it says, number one, what do you notice about the sunspots in the picture in the video? And then which part of the sun rotates the fastest? How do you know? I want you to go ahead and pause this video right now. And I want you to go to your worksheet and I want you to answer, does the sun rotate in place, numbers 1 and 2 only? You do not have to answer, does the sun rotate in place, just numbers 1 and 2. What do you notice about these sunspots and which part of the sun rotates the fastest? I want you to answer it now. Go ahead. Okay, so you should have answered number 1 and 2, and you should now be moving on through the video. If you notice, these are sunspots here, and in this picture you can see that the sunspots are aligned, and then they move one place over, and you can see that the one in the middle has moved a little bit further than the one at the top. And then as they keep moving, you can see the one in the middle has moved a lot further as the one on the top has not. So what you should have noticed about these sunspots is that maybe they're moving at different speeds, okay? And yes, the sun rotates, and we know that because we see these sunspots are moving. And so if I asked which part of the sun rotates the fastest, I'm hoping that you said the middle. Right? As you can see, they started at the same place, but the sunspot in the middle versus up here moved much more quickly than the other one. All right, and so we know that the middle of the sun or the equator of the sun moves faster because the sunspots move faster. All right, So we're going to go ahead and we are going to go with, actually, I'm gonna keep talking about the sun's rotation, sorry. And so big number to remember right here. If you don't remember anything else about the sun's rotation, this is what you need to know. It takes 25 days at the equator to fully rotate. So in the middle of the Earth, it's 25 days, or middle of the sun, excuse me. At the top of the sun, it's 35 days. So when you look at this sunspot takes 35 days to come back around. This sunspot takes 25 days to come back around. And so basically the sun rotates at different speeds, different parts at different speeds. It's called differential rotation. And basically it means that the north and the south poles move slower than the middle. And so it's not like Earth where everything moves in one nice place. All right. So before I start with the next slide, I want you to pause the video and I want you to go to this what is a sunspot part, and I want you to try to answer 1 and 2. I want you to try to answer 1 and 2. Take a pause and do that, and then we will come back to give you the answers. Okay, here we go. So by now you should have answered 1 and 2 for what is a sunspot, and we're going to talk about sunspots now. And so I want you to think, if the photosphere is where we see anything on the sun, where we see the light, where we can actually see the surface of the sun, we're looking at this photosphere. So if we see sunspots, then they have to be on the photosphere. And so the layer that we find sunspots on is the photosphere. The sunspots, they always look darker because they're lower in temperature. And there's a reason why they're lower in temperature, but I want you to know that they are lower in temperature. Right? So that should answer number 2 and number 3. You don't have to redo number 2, but you should answer number 3, and you should say that sunspots are darker because they're lower in temperature. Okay. So we're going to continue on, and rather than pause the video and try to answer the questions first, we're going to go over some things. I'm actually going to take this out. We're going to go over some things, and then you're going to answer the what is a prominence 1 and 2. So a prominence is basically, it looks just like this. It's just like a big burst of sun material. It comes through the surface, winds up, and goes right back into another surface. And if you notice some darker spots down here, that might become important, right? So what happens to the sun's magnetic field as it moves? The sun's magnetic field gets twisted up. So remember, I said that parts of the sun move at different speeds. And so if the magnets or the magnetic field in the center is moving much faster than the magnetic field at the top and the bottom, it ends up getting all twisted up. And when it gets twisted up, it bursts through the surface of the sun, and it comes back down into another part of the surface. Okay. And when it does that, it releases some heat, and so those areas cool down and they create sunspots. So the second question that you would have to answer is, how are sunspots related to prominences? So I want you to go ahead and I want you to take a pause in the video, and I want you to answer what is a prominence number 1 and what is a prominence number 2. Once you're done with that, you can get started again with the video. All right, now that you've answered what is a prominence 1 and 2, you should be ready to move on to the sun does what to Earth? All right, so here we go. There's a few slides for this, and I'm going to go over them one at a time, and I'll ask you to pause and answer your question, or answer your questions over here. So we know what a prominence is now. We know that it's just this big loop of solar materials, and it creates sunspots essentially. Well, solar flare is nothing more than just a prominence that like exploded off of the sun. It didn't go back into the sun. It just went out into space. And that is the major difference between a solar flare and prominence. One ends up going back into the sun. The other one explodes off into space. Go ahead and pause the video and answer number 1 under the sun does what to Earth? Okay. So number 2, how does a solar flare impact the Earth? All right. Solar flares and sun weather, anything that comes from the sun, has really big impacts on technology, especially here on Earth. Specifically, we're talking about satellites, radio transmitters, communications, cell phones, the radio that you would hear, anything that the military uses to communicate with each other. Solar flares and sun weather have a big impact on that. And most of the time we do get some solar weather. We get just a little bit. And that's the reason that we're able to see the northern lights up in some like towards the Arctic Circle, some of the northern states, Canada, Antarctica, anywhere at the poles, you'll usually see these things. I think Norway does a lot of things where you can go out and actually spend a few nights out there and see this every night. Actually very cool. And so sometimes we get some solar flare activity that causes this. However, in 1989, that was before Mr. Sava was born, that was our last major solar flare. And it was so big and so bad that it knocked out radio waves across the world. You could not communicate with anyone unless you talked to them in person. There was no radio available. There were no phones available. Everything was out. It killed the power in most of Canada. So Canada experienced a blackout for, I think they said almost 8 or 9 hours. They had no power in Canada. And these northern lights, where you usually only see them like up north, you could see them as far as Florida and even in Cuba. And so if we're scheduled for another big major solar flare at any point in time, you will definitely experience quite a crazy phenomenon here on Earth. All right, so go ahead, take a pause, and answer number 2 if you haven't already. And I will get started with number 3 here in a second. All right, here we go. So why are we protected from solar flares on Earth, but astronauts in space are not? And it has to do with Earth's magnetic field. Right? So solar flares don't kill us when we're here on Earth because we have a magnetic field and it soaks up that radiation. So as you can see here in the picture, we have a little bit of a magnetic field that extends out into space, and then the solar flares kind of hit it and it protects us and it goes around us, right? Kind of soaks it up, if you will. But it's limited. So sometimes if an astronaut is out in space, they're not in the full protection of the magnetic field, and they can be hit with dangerous solar flares and solar rays. Okay? So that's going to go ahead and end our lesson here today. You should have all questions answered. Make sure you turn this in when you're finished, either on Focus or on Teams, whatever is working best for you. Hopefully it's on Teams. That makes it easier for me. So that is it. Hope you enjoyed the lesson. If you have any other questions about this, please put them on the questions and answers page. I hope you're curious, and I look forward to seeing what you have to say.